Okay, so welcome back for part two of 16E. I'm just going to run through a few examples. First example, if z1 equals 3 cos pi on 2 plus I sine pi on 2, and z2 equals 4 cos 5 pi on 6 plus I sine 5 pi on 6, we have to figure out what z1 times z2 is in polar trigonometric form. Step 1. Remember, for multiplication, we're going to add the arguments of z1 and z2, or the complex numbers we're multiplying together. The argument of z1 is pi on 2, and the argument of z2 is 5 pi on 6. So if we add these together, we get pi on 2 plus 5 pi on 6. And this will be something like 8 pi on 6. Just bear in mind that we want this argument to be a principal argument. And 8 pi on 6 does not fall in our domain of principal arguments. It's beyond pi. So we need to rewrite 8 pi on 6 as being within the principal argument domain. So remember that 8 pi on 6, you can write this multiple ways. I'm going to separate it into 6 pi on 6 plus 2 pi on 6. That's the same thing, plus pi on 3 when simplified. And I can easily see where this is on my plane. So pi plus pi on 3 will put me into that third quadrant. So I can rewrite 8 pi on 6 as negative, going around anti-clockwise from the real axis, 2 pi on 3. And that will give me the same point or the same angle as 8 pi on 6. So now I've written this argument in principal form, and it is minus 2 pi on 3. So I've got the argument. That's great. Now all I need is to find the modulus. And we do that by multiplying the moduli of z1 and z2 together. So the modulus of z1 is 3, and the modulus of z2 is 4. Oh, how nice is that? Because 3 times 4, well, I know that should be 12. Now I just combine these together, okay, and put it in polar trig form. So z1 times z2 in polar trig form, the modulus we said was 12, and my theta is minus 2 pi on 3. So z1, z2 is equal to 12 cos minus 2 pi on 3 plus I sine minus 2 pi on 3. An example of division. So this time we have z1 and z2, and we're going to divide them and express them in two different forms. The first is in polar trig form, and the second is in Cartesian form. So step 1, for division, we subtract the arguments of the complex numbers we're dividing by. The argument of z1, well, that's pi on 3. And the argument of z2, well, that's 2 pi on 3. Make sure you write this in the order of the division. Pi on 3 minus 2 pi on 3, well, that's minus pi on 3. And this is good because this is within the domain of our principal argument. This is between negative pi and pi, so we're all good. Step 2, instead of multiplying the moduli like we do in multiplication, we do the opposite and we divide them. The moduli of Z1 is 3 and the modulus of Z2 is 2. So 3 divided by 2, well, that is just very nicely 3 over 2. So we have the new modulus is 3 over 2. For part A, we just need to write this in polar trig form, which we know how to do. Z1 over Z2 will become 3 over 2 brackets cos minus pi on 3 plus I sine minus pi on 3. Part B says express this in Cartesian form. And we know how to express a polar trig form into Cartesian form. Just evaluate the trig. Now we simply convert this into Cartesian form by evaluating the trig. I'm just going to sketch in minus pi on 3 into a diagram so I can figure out what cos minus pi on 3 is and sine minus pi on 3 is. Use your identity triangle and recall that cos is the only trig function that is positive in Q4. So therefore I'll get Z1 over Z2. 3 on 2 stays the same. Positive a half for cos of minus pi on 3. And negative root 3 on 2 for sine minus pi on 3. When we expand, we'll get 3 on 4 minus, we'll get 3 on 4 minus 3 root 3 on 4 I. So now we have two forms of Z1 divided by Z2. So you can have a go at the 16E part 2, the chapter review, and also there's a chapter review in the exercise book that's a revision of chapters 13 to 16, and that is just chapter 17 in the textbook, and that might be a good idea to do over the holidays at some point. And keep in mind that if you ever feel like zero, that you're really no one, remember that you're just important as zero, because zero is the origin and it's the reference point for absolutely everyone.